African Humanities Association. Ladies and gentlemen, it's my distinct honor to welcome Professor Nanaba Appiah-Ampho, Vice Chancellor of the University of Ghana and Chairperson for this evening's lecture.
Lady Chancellor, Ministers of State, Members of Parliament, and other government officials present, Justices of the Supreme Court and other judges herein present, our distinguished lecturer, Professor Gordon Akanzewini Awandare, Registrar, Provosts, Deans, Directors, and Heads of Departments, former Vice Chancellors, Pro-Vice Chancellors, Registrars, and other officers of the University of Ghana, Vice Chancellors, Pro-Vice Chancellors, Registrars, and other senior officers of other tertiary institutions, the IGP, Dr. George Akufu-Dampare, and senior officers of the Ghana Police Service, corporate executives, members of the diplomatic corps, esteemed traditional rulers, eminent clergy, faculty, staff, and members of convocation, alumni and students, family and friends of the lecturer, invited guests, ladies and gentlemen from the press, distinguished virtual and in-person audience. Good evening to you all. I'm excited to preside over this evening's inaugural lecture to be delivered by one of my able lieutenants and an illustrious son of Kandiga in the Upper East region. He's a man of many hats, the foundation chairman of the Governing Council of C.K. Tedem University of Technology and Applied Sciences in Navrongo, and more importantly for us, our Pro-Vice Chancellor with responsibility for academic and student affairs, who doubles as founding director of the West African Center for Cell Biology of Infectious Pathogens, WAGBI. This evening's lecture puts the spotlight on the sustained research work of Professor Gordon Awandare and his contribution to his field of study, cell and molecular biology, immunology, and genetics, and to humanity. In December 2019, there was an international news headline aired on our screens about the outbreak of an infection in Wuhan, China. At the time, many of us thought that it was one of those health issues which would resolve in a matter of weeks, especially for us in Ghana having escaped Ebola. We certainly thought we would escape this one too. Little did we know that it was to become a global phenomenon with a magnitude to grind the world with all its hustle and bustle to a halt. In March 2020, the World Health Organization declared a global pandemic. The world was plagued with a contagious, fast-spreading and deadly virus, the severe acute respiratory syndrome coronavirus 2, generally known as COVID-19. This was an infection scientists barely knew about. Hospitals were getting choked, mortality rates, particularly in the advanced countries, were alarming, and the world was plunged into its new normal with its accompanying restrictions, lockdowns, and travel bans, among others. Though there were predictions of higher fatalities in Africa, thankfully we did not experience that. Perhaps God spared us because even without any extraordinary occurrence, we didn't have enough hospital beds to attend to daily emergencies, and our inadequate health infrastructure may just have crashed had those predictions materialized. Some suggested that the scorching sun in Africa was possibly responsible for killing the potency of the virus. Whatever it was, most of us were just grateful to God that the intervention which shielded us from the full force of the virus. As we were busily thanking God, Professor Awandare and his team were fixated on understanding the science underpinning this occurrence. This evening, as he takes us through his academic journey, his focus through this lecture is on how our immune system acquires tolerance to malaria and helped us survive COVID-19. Reading from his abstract, it was evident that apparently our frequent disposition to malaria right from childhood made our immune system a bit more tolerant to COVID-19. In the heat of the pandemic, several units of the University of Ghana played diverse roles and significantly contributed to understanding the pathogens, biology, and disease mechanisms to generate knowledge for the development of diagnostics, vaccines, and drugs. Two of such units, which were outstanding, was the Noguchi Memorial Institute for Medical Research and the West African Center for Cell Biology of Infectious Pathogens, WACBIP. If the media needed credible information devoid of political undertones, they either spoke to the COVID professor or any of his able team members. Through this inaugural lecture, the University of Ghana celebrates the remarkable achievement of Professor Gordon Awandare, who is not only knowledgeable in the investigation of infectious pathogens, but has also been at the forefront of some major discoveries on malaria and has conducted significant scientific inquiry on the genetics of hearing impairment, particularly in Ghana. As a research-intensive university, we take pride in our formidable researchers whose stellar performances has contributed to our global ranking as the leading university in Ghana, according to the recently published 2023 Center for World University Rankings. Not only is Professor Gordon Awandare adept at investigating the cell biology of infectious pathogens, but he also has an outstanding record of winning grants and building research partnerships across the world, which has advanced scientific equipment, infrastructure, fellowships, and postgraduate training at the University of Ghana. He was recently appointed by the President of the Republic of Ghana as a member of the founding governing board of the National Vaccine Institute of Ghana as a result of his proven capabilities. With the World Health Organization's recent declaration that COVID-19 is no longer considered a pandemic, I suppose it's a good time to relax and understand how God spared Africans from the full rigors of the infection. And now, distinguished audience, please permit me to share a brief bio of our lecturer. Professor Gordon Akanzuwene Awandare is a professor of biochemistry, cell and molecular biology, and the Pro-Vice Chancellor responsible for academic and student affairs here at the University of Ghana. He's also the founding director of the West African Center for Cell Biology of Infectious Pathogens, and a visiting professor at the Faculty of Health and Life Sciences, Oxford Brookes University, Oxford, in the UK. Professor Awandare completed his O-level in 1991 at Notre Dame Seminary Secondary School, Navrongo, and his A-level at Presbyterian Boys Secondary School, Legon. His bachelor's and MPhil, both in biochemistry, is from the University of Ghana, and his PhD in infectious diseases and microbiology is from the University of Pittsburgh, Pennsylvania, USA. While studying for his master's degree from 1999 to 2002, Professor Awandare worked as a research assistant at the immunology unit of the Noguchi Memorial Institute for Medical Research here at UG and at the Unité d'Immunologie Moléculaire des Parasites, Institut Pasteur, Paris. After obtaining his master's degree, he was appointed lecturer in the Department of Biochemistry in 2002. He obtained his PhD in 2007. after which he worked as a scientist at the Division of Malaria Vaccine Development of the Walter Reed Army Institute of Research, Silver Spring, Maryland, until 2010, when he returned to the university to establish his research group. He was promoted to senior lecturer in 2011, associate professor in 2015, and professor in 2018. He was head of Department of Biochemistry, Cell and Molecular Biology from 2013 to 2017. In 2014, he led the establishment of WAGBIB after winning one of the World Bank African Centers of Excellence grants and becoming the founding director of the center. He was appointed Pro-Vice Chancellor for Academic and Student Affairs with effect from January 2022. Professor Gordon Awandare has expertise in cell and molecular biology, immunology, and genetics. His research works encompass both infectious diseases and non-communicable diseases, with a focus on understanding pathogen biology and disease mechanisms to generate knowledge for the development of diagnostics, vaccines, and drugs. The majority of his research output is on malaria, including investigating mechanisms of red cell invasion, innate and adaptive immune responses, and the role of human genetic variation in influencing disease pathogenesis. He played a leading role in the discovery of complement receptor 1 as a major receptor used by malaria parasites to invade the red blood cells. He has more than 150 peer-reviewed journal publications in a wide range of journals, including some of the leading infectious diseases and immunology journals. He has supervised 14 postdoctoral fellows, 20 PhD students, and 23 master's students, and mentored many young scientists in Ghana and across Africa. Professor Awandare has an outstanding record of winning grants and building research partnerships across the world. He has successfully managed several large multinational and multidisciplinary training and research projects involving many high-level academics and multi-million-dollar budgets. Since 2011, he has directly attracted over $40 million in grant funds to the University of Ghana, including winning highly competitive grants, including 2 World Bank African Centers of Excellence grants, valued at $14.5 million, and 2 Wellcome Trust Deltas awards amounting to $11.5 million. These grants have provided advanced scientific equipment, infrastructure, and fellowships to more than 350 African scientists for master's, doctoral, and postdoctoral training at the University of Ghana. Within the University of Ghana, Professor Gordon Awandare is currently the board chairman for the University of Ghana Enterprises Limited. He chairs the implementation committee for the Vice Chancellor's Classroom Modernization Project, as well as 9 statutory boards and committees. He's also chaired or served on several ad hoc committees at the University of Ghana, including the Search Committee for Vice Chancellor in 2020-2021. At the national level, Professor Awandare is currently the foundation chairman of the Governing Council of the C.K. Tedem University of Technology and Applied Sciences in Navrongo. He has previously served on the Governing Council of the University of Development Studies, Tamale, where he is also the chairman of the university's Audit Report Implementing Committee, where he was. Professor Awandare is a member of the advisory board of Yamachi Biotech, a biotechnology company in Accra, which was founded by one of his mentees. He was recently appointed as a member of the Foundation Governing Board of the National Vaccine Institute of Ghana. Professor Awandare serves on numerous prestigious international boards and committees, too numerous to recount here. You have the full details in the brochure, whether through the hard copy or a soft copy. Professor Awandare was a recipient of the Royal Society Pfizer Award for 2015 for achievements in molecular and cellular studies of malaria and science capacity building in Africa. At the University of Ghana, he received the Distinguished Award for Meritorious Service in 2014, Citation of Honor in recognition of contributions to science development in the College of Basic and Applied Sciences in particular and the University of Ghana in general in 2020, and Meritorious Award in recognition of outstanding service, College of Basic and Applied Sciences in 2021. He's a fellow of the Ghana Academy of Arts and Sciences and the Royal Society of Biology of the UK. In 2019, he was appointed the first global editor for Africa for Experimental Biology and Medicine and the Journal of the Society for Experimental Biology and Medicine. He has been profiled in some prestigious global media, including the Scientist magazine, in recognition of his impact on science capacity building in Africa, and Kenyan Airways Msafiri magazine as one of Africa's brilliant minds. Professor Gordon Awandare hails from Kandiga in the Upper East region. He was born in Bolgatanga in November 1974 to Mr. Joseph Atoria and Mrs. Immaculate Atoria, who were both teachers. He's the first of 4 children of his parents, and his siblings are Eunice, Jerome, and Flavia Awandare. Prof. Awandare is married to Mrs. Masa Awandare, and they have 3 children, Marie, Gabriel, and Jeremy. Prof. Awandare is from a big extended family and has many close aunts, uncles, nieces, and nephews. Distinguished ladies and gentlemen, this is a brief profile. The full profile will take us the whole evening, right? But it is now my singular pleasure to invite Professor Gordon Akanzuwini Awandare. Trained the human immune system to tolerate COVID-19, protecting us from severe disease and death. I'm eager to hear more, and I'm sure you are eager too. Prof. Awandare, thank you.
Banzalambia, Waralibe, and Dunia Balanda. President, everybody understands, but I'm probably on the Banza. no kuchanta biabne ko para. Open na nyo secondary. On na kabzani mane kakana University of Ghana. Ntino BSCL, kano MPHDL, kabzani mane, kaza otom ngufurka sala, nchan University of Pennsylvania, ntino PhD. Ni mane ko yinkana ntibzani kakpa langu, kabwale ula, kabwale ni wakib. Wakib ma ka University di danfane hanuzo na di danfane. Professor, opa yulumbo ni masa. Awandare kamar bi hata to nun suka ce ya tali ye tupur tali ye una andani tali impura tali.
My name is Awandare. I did my PhD at the University of Pittsburgh. Then after that, I did a postdoc at the Walter Reed Army Institute of Research in Silver Spring. And in 2010, I packed my bags and I came back home to Ghana to start my independent career here. Basically, the motivation for coming home was that I thought that the skills that I had were much more needed here than where I was. WAGBIP was established as one of the World Bank African Centers of Excellence. And the inspiration behind it is basically that a number of us who were at the Department of Biochemistry and the Noguchi University for Medical Research, we had trained outside, and we did PhDs in various science disciplines outside the country. And so when we got back and realized that there was not much by way of facilities to train scientists, we saw this as an opportunity to create an environment which would enable many young scientists to get the opportunity to get the quality of training that we got overseas. Really, the driving force was to try to create a world-class research and training environment where young African scientists from across the continent can come here and develop their talent and do high-quality research that can be comparable to research that's done in any part of the world. So basically that was the mission that we were pursuing.
In Africa, infectious diseases remain the leading cause of morbidity and mortality in the population. But non-communicable diseases are starting to catch up with infectious disease and even surpass. It's estimated that by 2030, non-communicable diseases will present the greatest burden on health on the continent. We are using two main approaches, the research and the training or capacity building. We are going to use advanced molecular methods and cellular approaches. So we are seeking to understand disease mechanisms, whether infectious disease or non-communicable disease, by looking at what happens at the cellular and the molecular level. For the infectious disease, we study pathogen biology and trying to understand how the pathogens cause disease and how we can use that knowledge to develop new and better diagnostics, new targets for vaccines, and identify potential pathways for drug interventions. On the non-communicable disease side, we will use genetic approaches to try to identify genetic signatures or markers that are associated with certain diseases or which run through certain families. These can be the basis for developing early diagnosis, which is crucial for determining the outcome of non-communicable disease. So that's for the research side. Then we have the capacity and the training, where we identify some of the best and young scientists on the continent, and then we provide them with the skills and the tools that are necessary to undertake research and to also contribute to public health interventions in their various countries. The research is also getting more exciting because we are asking new research questions, especially now with the opportunity to look at the interaction between infectious diseases and non-communicable diseases. We get the opportunity to study the interaction between these two and see how infectious agents could precipitate or accelerate the development of non-communicable disease. And we want an Africa which is doing cutting-edge science with young people leading science, developing new innovations in health, including diagnostics, developing new drugs, developing new vaccines, so that when we have the next pandemic, we'll be developing our own vaccines. Who knows, maybe the next emerging pathogen would be from Africa, and we will be the first to respond.
Throughout my academic journey, I'd always look for opportunities to come back home. My plan has always been to establish myself, to spend my most productive, my most useful years in Africa and hopefully in Ghana. So during my second postdoc, I actually met Prof. Awandare, the director of Awandare in London, and we came to actually receive an award. That was the first time I heard about Awandare. And so hearing about Awandare, hearing what Prof. Awandare was trying to do in Ghana, I felt that it was a place that would welcome someone like me, a place that someone like me potentially could thrive. It was basically a fulfillment of something I'd always wanted to do. And Wagrid stood out as a place that, even though it was a young center, was led by somebody who himself was very dynamic, who identified a lot of the ideals that I myself identified with. And so it was somebody that I thought I could work for.
Ladies and gentlemen, we are meeting here at a time where the COVID pandemic. And as African scientists, there are many lessons we take from this unfortunate era. Some are positive, and we like to dwell on the positive ones. But we have to acknowledge the challenges that we've had to contend with, and which would inform our strategy for going forward. One of the first lessons that we learned is that African scientists have to tell our own story. And that's why we're here. We have to tell the story of how the pandemic unfolded on the continent. We have heard various versions of how the pandemic unfolded in Africa. On the one hand, there are people who have never been to Africa, but who have used modeling to predict that the continent will be wiped out due to the pandemic. On the other hand, we have another group of people who think that Africa did so wonderfully, and that we controlled the virus, and that the virus didn't spread here as much as it did elsewhere. Again, we think that is false and misleading. Our research shows that indeed the virus spread here very well and spread fast.
And the fast is our advantage.
Madam Chancellor, Madam Vice Chancellor and Chair, members of Council present, Provost, members of senior management, former members of senior management, the IGP, my friend, Dr. Dampari, and his strong team here. Thank you very much. Present and former ministers and members of parliament, deans and directors, vice chancellors, registrars, pro-vice chancellors from our sister universities, heads of department, distinguished guests, ladies and gentlemen. It is a great honor to be supported by so many people here today. In fact, over the last few weeks, the kind of support that I've had, I'm thinking that I may have to start a church. I hope my Catholic pastor is not here. It will be a breakaway Catholic church. But I am so grateful that all of you took the time to be here. My family is here, and I'm so grateful for the support they've given me. Madam Chair, as you noted, I became a professor quite a while ago, and indeed some of my children's friends asked them that, but your father has been a professor, or why are you now doing this celebration of professorship? Madam Chair, yes indeed, this lecture is about 4 years old, or 4 years late. But one of the reasons why the lecture is 4 years late is because of the COVID pandemic. And based on what we are going to do here today, it seems that supreme wisdom wanted this lecture to be done today. Because the story of African science, the story of the University of Ghana, the story of Wagbit, and my career would not have been made or would not have been done proper justice if I had given this lecture before the pandemic. Indeed, the pandemic changed the world as we know it, and it changed my career too. If I was giving this lecture in 2019 or early 2020, I would have talked about malaria and malaria parasite biology and how we can develop malaria vaccines and why we haven't got malaria vaccines yet. That's what I would have talked about, which is also very important, of course. But today, the ground has shifted. And so I have made adjustments to acknowledge the new reality and the new things that we've learned and the efforts that we've put in. And to honor our family and friends who lost their lives. So today, I'm going to talk about malaria and COVID-19. As it would have it, there's a good story to be told about the two diseases. I spent my life working on malaria and trying to understand malaria pathogenesis and malaria immunology and how we develop natural resistance to malaria. And I with my team, we found a lot of new things. We discovered many things. And one of the things we learned was that we have to develop tolerance to the disease and then the tolerance to the parasite in order to survive malaria. And this tolerance has been fascinating to us for a long time. And so when COVID came, and as you know, the symptoms of COVID were very similar to malaria. COVID was a disease that the majority of people were asymptomatic, which is similar to malaria. And at the molecular level, I'll tell you how similar it also is to malaria. And based on that, we were trying to understand what is different and what is similar between these two diseases. So, distinguished ladies and gentlemen, over the next I'll try to do 1 hour and 15 minutes. So you are all my timers. Tell me. I will try to tell you what we've learned about malaria and how we think that has shaped our response to COVID-19 in terms of our immune response. So the presentation will be in 3 main parts, but with an introduction and with acknowledgements. So the first main part will be talking about malaria. The second part will talk about COVID. We'll review some of the theories that have attempted to explain why we didn't die on the street in Africa. Indeed, I would attempt to present a unifying hypothesis that would make everybody happy. And then in the last part, I will talk about capacity building. In addition to research, many of you know that my passion is on building capacity for African-led science so that Africa can be competitive. So we talk about the progress that has been made as a continent and what we have done at WAGBIP to contribute to that progress. I would acknowledge people, or I will attempt to acknowledge people, knowing that I will leave many out. So, ladies and gentlemen, the story that I'm going to tell is about inflammatory responses, inflammatory immune responses. And inflammatory immune responses have been part of my research journey. Around about 1996, 1997. After I was rejected from the medical school, you know, those days, you come to University of Ghana, that you want to do medicine, and then you all do biological sciences in level 100. Oh, sorry, level 200. We didn't have level 100. So we do biological science in the first year. And then after that, they will winnow us down and select us for interview. And then after the interview, they select those who are chosen to be doctors. As many of you know, they did not find me worthy. And like I said at my exhibition on Monday, I think they were right. I don't think I would have been a good doctor. So medical school, I forgive you. Your selection panel were good. They did the right thing. Because many of you know that I do not conform. And I defy rules. And I do what is supposed to be done. Okay? And I don't think doctors are supposed to behave that way. So I think research is what I was meant to do. So I think the panel were right. So thank you, panel, for showing me the way. So anyway, I was then left to do biochemistry. So at the Department of Biochemistry, I was assigned to a very superstar, popular professor that many of you know, Professor Marian Eramadi. She started a now very popular, brilliant Science and Maths quiz. It's now called something else, but the Science and Maths quiz, which have become very popular. She started that. But she was one of the leading professors in this country, especially of, who were women. So anyway, she was also one of the few people who had grants in the university who had the ability to do research. So I was fortunate enough to be assigned to her. And at the time, she was doing a project screening herbal products for their anti-inflammatory activities, because she was interested in asthma and arthritis and all these inflammatory diseases and the kind of herbal products that can be used to treat them. Anyway, so I had a project with her screening herbal products for anti-inflammatory properties. Okay? So that was my first introduction to inflammatory processes and inflammatory mediators. Then, based on that experience, I applied for a master's fellowship at the Noguchi Memorial Institute for Medical Research on a project that was led by Professor Akamori. I hope Professor Akamori is here. Professor Akamori is over there. Thank you very much, Prof. So, Professor Akamori went through a process to select 2 students, myself and my friend Gideon Helegwe. And my experience with inflammatory mediators was very helpful, because the project that he wanted to do was to look at inflammatory responses in children with malaria. Okay, so that led me to work with Professor Akamori at Noguchi. We did a lot of work, and I'll show you some. Then, with my inflammatory response data, I attended a research conference in Tanzania where I presented my work. And it's a long story, but the short of it is that I met a man called Douglas J. Perkins, who was presenting at the same session that I was presenting. And after I presented, he asked me whether I was a postdoc. And I said, no, I'm not a postdoc. I don't even have a PhD. And he said, wow, that was good. And then he said, see me after the session. Ladies and gentlemen, that's a long story short. I applied to University of Pittsburgh where he was, and he gave me a fellowship to do my PhD. And that's how I went to do my PhD. And again, it was because of my knowledge of inflammatory mediators. Because he was interested in inflammatory mediators, but the genetic aspects of these inflammatory response genes. And so that led me to Pittsburgh, where we also did a lot of work and published many, many papers. So today, I would give you a small background about immune responses, and then we would narrow it down on inflammatory responses. So as we all know, when our system is breached by a pathogen, we have what we call the physical barriers, physical and physiological barriers, which is your skin, your mucous membranes, eyelashes, and all these things. They help to stop, the pathogen from getting in. Beyond that, we have what we call the innate system. And the innate system has 2 parts. We have the part that is non-specific at all. That means that every pathogen, it will respond the same way. Okay, so it's blind to pathogens. So that's non-specific innate immune response. And that happens normally quickly. Then followed by what we call a broadly specific immune response, which normally is a little bit more specific. So it targets groups of pathogens or categories of pathogens. And then the best one comes later, which is what we call the adaptive immune response, which takes time, but it responds specifically to the pathogen that is invading you. So it involves what we call T cells and B cells, but the main thing that comes out of that is antibodies, which you've heard about. So antibodies help us to clear pathogens, and that comes out of the adaptive immune response. Now, I've shown here a picture of various other physiological and anatomical immune response systems. Now, one of the important things about immune responses is that it needs to be regulated. Because too much of a good thing is is dangerous, as you know. So if you don't regulate the immune response, you could have undesired effects. So if it's well regulated, you would achieve destruction of pathogens, you can destroy cancer cells, and so on and so forth. But if it's not well regulated, you can lead to allergies, you can lead to transplant rejection, autoimmune disease, and immunodeficiency. And for our case, you can have hyperinflammation or too much inflammation. At the center of inflammatory responses are proteins that we call cytokines. Cytokines are sort of like hormones because they are produced by different cell types, and then they have an effect on the same cell type or other cell types. And normally, this is how cells communicate. They use cytokines to communicate with each other. And the way the cytokine has this effect is that it will bind to the outside of the cell, and it will transmit a signal to the inside of the cell and elicit certain responses in the cell. And that's how cytokines work. Now, I told you that I did a lot of malaria work, and here I've summarized the different types of malaria work that we do. You'd see that we do nearly every aspect, and we take advantage of people who donate their samples to do as many types of analysis as possible. So today I'll be telling you about the immunological studies that we've done, but we've also done a lot of vaccine discovery, we've done diagnostics, we've done clinical hematological analysis, we've done genomics, as you know, we've done red cell invasion mechanisms, we've done drug studies, we've done a lot of malaria work. Sorry. And I want to acknowledge that in my group, I have 5 strong men who lead the lab when I'm on the street or having meetings. And these people, I've shown them here, Lucas Amingaidiko, Yawaniwe, Prosper Kanyong, Emmanuel Amlabu, and then Yaobediaku. So we've divided the group into different thematic areas, and they lead each of the thematic areas. We have many people in the group, including postdocs, PhD students, master's students, research assistants, and research interns. So we know that when a mosquito bites us, an infected mosquito bites us, they inject the parasites into our skin. The parasites find their way to the liver first. But in the liver, we don't feel anything. We don't know that we are even infected, unless you can remember the mosquito bite. But you don't feel any symptoms. You only feel symptoms when the parasites get to your blood. From the liver, they find their way to your blood, and then that's where the party starts for them. So I'll show you this video as you watch. That's a red cell that looks like a donut, and a parasite, the green particle is a parasite. That's what we call a merozoid. And it finds its way into your red blood cell, and then takes time and enjoys the red blood cell, multiplies, and makes many more new parasites. And when it's ready, it will burst out of the red cell and release many more new parasites, which will then invade new red blood cells, and the cycle would continue. And that is how we start to feel the symptoms. So you can see that the parasite has just burst, and now new ones are looking for new targets to invade. And this is the cycle that happens in the blood. So on the left side, you see pictures from our lab of different stages of the malaria parasite in red blood cells. Now, when there's this burst, there are many parasite products that are released, what we call antigens. And these stimulate the immune system. And then that is when some of the responses begin. So how do we know that we have malaria? Well, like I mentioned, one of the unique things about malaria is that you can have the parasites and still be fine and not even know. That's what we call asymptomatic infection. I'm sure now everybody knows asymptomatic because COVID, we use that word a lot. The beauty of COVID is that we all started to enjoy science. Now they don't talk to us anymore because they are not scared. Anyway, but asymptomatic infections are what the majority of us have, those of us who live in malaria endemic areas. If I tested you now, a significant number of you will be carrying malaria parasites, but you wouldn't know. So you have asymptomatic infections. And those are the infections that we're interested in because you have developed tolerance to the parasite. You can live with the parasite. Okay, so we'll be talking more about how you're able to live with the parasite. Okay, so, but if you are not able to tolerate the parasite, you can have mild symptoms or uncomplicated malaria, which will be the normal fever, headaches, and a little bit of fatigue. But if you are a small child, or if you have not been exposed before, or if you are a traveler from a non-malaria endemic area, you could have severe malaria. And this could be hyperparasitemia, could be anemia, could be hypoglycemia, could have multiple organ dysfunction, which is also similar to COVID. You can have what we call metabolic acidosis, acute respiratory distress, or cerebral malaria, which is one of the killers in malaria. Now, why do we have all these different types of presentations? Well, we know that transmission intensity is a factor because if you're in an area where there's no malaria, then the first time you get malaria, you're likely to get severe malaria, and you could die from it. Related to that, it's your age and immune status. If you are in an endemic area like here, that means that the older you are, the more likely you have immunity to malaria because you have had several kisses from the mosquito. And then host factors. We know that host genetic factors such as sickle cell protect us from malaria. That is a fact that we don't want to talk about today, but that's something we have also established in our research as well as others. And then your immune response, the nature of the immune response, which is what we will talk about today, as well as other factors that we're still trying to learn. So I'm just going back to the work that I did with Professor Akamori with colleagues at Noguchi. At that time, we were trying to characterize malaria in Ghana. And so this study, you would see that we tried to characterize the different categories of disease. So you see, we separated them into uncomplicated malaria. I apologize, the figure quality is poor because it's very old. But we separated them into cerebral malaria, uncomplicated malaria, severe anemia, respiratory distress, and then what we call severe malaria combined. That is either cerebral malaria or severe malaria anemia. But what was striking was, if you look at the mortality rates, overall was about 5.6. But if you look individually, cerebral malaria was very high. And if you saw anybody with respiratory distress, together with any of the other symptoms, the mortality was nearly half. And that was something that was very striking to us. I'll come back to that in a second. But I just want to remind you that once the parasite bursts in your blood, you're going to have the immune response. You're going to have an innate immune response, and you're going to have the adaptive immune response. I've already told you how those work. In the innate immune response, you have these cytokines, including interleukin-1. If you see IL, that means interleukin. Interleukin-1, TNF-alpha, interferon gamma, nitric oxide. Some of these mediators are produced when the malaria parasite bursts into your system, into your blood, and stimulates your immune response. And these are part of the early responses that we mount. For the specific response, we are lucky that our mothers pass on antibodies to us. So for the first 6 months of our lives, once our mothers lived in an endemic area, they would have some antibodies that they would pass to us. So we get to enjoy free immunity for 6 months. After that, we start to develop our own immunity. But in endemic areas, normally after 3 years, we start to develop tolerance. So we start to learn how to live with malaria parasites, and we'll talk a little bit more about that. And then eventually you acquire specific immunity against the parasite through antibodies. So what I'm saying is that natural immunity to malaria has two components: anti-parasite immunity, which consists of the antibodies and other specific immune responses, and then what we call anti-disease antibody, okay, or what you call anti-disease immunity, or what you call clinical immunity. The figure I'm showing you is one of the classical studies on malaria, where they show that people living in different areas with different transmission intensities or different levels of endemicity, they acquire this level of natural immunity at different times. So if, those that plateau early are those who live in high transmission areas. So by age 2 going to 3, they've already had sufficient malaria that they become immune or tolerant to the disease. Whereas if you live in a low transmission area, like the one below, there's not a lot of malaria, but you see that the line keeps to rise even up to the age of 10 because you don't get sufficient exposure to the parasite to develop resistance. So what this means in terms of your antibody response, this is data from one of my PhD students called Henrietta, and using children in Kintampo, samples from children in Kintampo, we show this phenomenon where antibodies are acquired with age, as you can see, as age increases. These are antibodies to different malaria-specific antigens. They start to rise. Now, I'll take you back to the study that we did in Noguchi with Prof. Akamori. And remember that respiratory distress was the biggest killer. What we saw when we looked at inflammatory mediators was that the unique thing about children with respiratory distress was that they had high levels of inflammatory mediators, okay? And moreover, the balance of inflammatory mediators between pro-inflammatory and anti-inflammatory was in favor of the pro-inflammatory mediators, which meant that these people had an over-aggressive pro-inflammatory response. And so this is something that formed the foundation for some of the work I'm going to show you. Now, how would inflammatory mediators cause so much severe disease and mortality? I've already mentioned some of the mechanisms. Could be metabolic acidosis, which leads to respiratory distress. You have impaired monocyte and macrophage function, which is a phenomenon that happens when cells are overactivated. Then they sort of shut down, and then you become exposed to opportunistic infections. You can have multiple organ failure because of high levels of pro-inflammatory cytokines. Your red cells could lyse, and then production of new red blood cells could be inhibited. And then these inflammatory mediators make your blood vessel walls sticky. That means there's increased expression of adhesion molecules, which means that parasites can then stick to the inside of your red blood, your blood vessel walls, and that will lead to blockage. And that is one of the mechanisms by which you start to get what you call cerebral malaria, or you go into a coma. So when I came back to Ghana to start my research group, one of the things that was very intriguing for me and where I wanted to stake my claim as a scientist was to use the differences in transmission intensity that we see in Ghana. I think that is quite interesting or cool that in Ghana we have different parts of the country with, very different transmission intensities or levels of malaria. In Accra, where we sit, malaria is very low, okay? And that's why many of us, we can't remember the last time we got malaria because malaria is very low here. If you go to the middle belt, where it's wet most of the year, you have a lot of malaria there. So in the middle belt, you could have as high as 250 infective mosquito bites in a year if you live in the middle belt. If you live in Navrongo, you could also have at least 100, but up to 250 infective mosquito bites in a year. But in Navrongo, it's very seasonal because it rains for a short while and it's dry season. So a lot of the transmission is during the rainy season. Okay? So that makes it also unique in its way. But anyway, I was fascinated by the fact that we had 3 distinct areas where I could work, where malaria transmission was different. And so we set up sites in these areas, and I want to acknowledge all these people who helped us to set up these studies. These were studies that are set up with the first grants that I got from the National Institutes of Health USA and the Royal Society UK. And using these funds, we set up field sites with colleagues in Navrongo Health Research Center, Kintampo Health Research Center, and the Lekma Hospital. Dr. Charlene Keba is here, who was at Lekma at the time and helped us set up the studies there. And we've continued to have lasting partnerships with these institutions. But it was very fascinating for us because when you look at the children that we recruited into the study, I don't want to bore you, so I'll go direct to where it's interesting. Look at the levels of parasitemia. That's the number of parasites per microliter of blood. In Kintampo, on average, 148,000 parasites per microliter of blood. In Navrongo, 46,000 parasites per microliter of blood. In Accra, about 38,000 parasites per microliter of blood. So it was very interesting that children in Kintampo would be walking around with 140,000, almost 150,000 parasites in their blood. And then we looked at their temperature, which tells you the intensity of the fever. If you look, you see that despite having lower parasite levels, children in Accra had a higher fever. In fact, those in Kintampo, the doctors will tell you they hardly had a fever. If you look at the temperature that's there, they hardly had a fever. But they have 150,000 parasites on average. Okay, and this is average. Some of them had 500,000 parasites. Okay, so this was something that was very striking to us because it told me and it told my team that there's something called parasite tolerance. Okay, people in Kintampo have some tolerance to parasites. So that was something that was interesting for us to do. So, given my knowledge of inflammatory mediators, you would remember, I was curious to find out how these children in the different areas produce inflammatory mediators. And you would see in these graphs that very clearly, children in Accra made much more inflammatory mediators than those in Kintampo. Accra is in green, Kintampo is in red. Okay? And this was also very fascinating to us because it sort of correlated inversely with the level of parasitemia. And so we were wondering, these cytokines are supposed to be produced in response to the parasites. So how come you have more parasites and less cytokines? And then you have less parasites and more cytokines. Okay? So we did some regression analysis, and you see here, it's difficult to see, but what you see is that the lines that show some level of correlation are for children in Accra. Those that are flat are for children in Kintampo and Navrongo. What that tells you, with if I remember my statistics well, is that there's a disconnection between parasites and cytokine levels in Kintampo and in Navrongo. Whereas in Accra, there's still some relationship that more parasites you have, more cytokines that you produce. Again, this confirmed to us that people in Navrongo and Kintampo who are exposed to high levels of malaria transmission have tolerance to malaria parasites. That's why they basically ignore the parasites. Okay? So to study this further, one of our PhD students working with Dr. Awandare took this further and designed a longitudinal study. Longitudinal means you follow the children up for a period of time rather than just studying them on one day. And so we took samples on day 0, that's before we gave them treatment, then day 7 and day 21, okay, after treatment. And then we measured the level of cytokines. This was done in Kintampo where we expect to see tolerance, okay? And there's a lot of data, but I'll just point you to 2 of them. So these are some of the classical inflammatory mediators. You would see that for these 2 mediators, in children in Kintampo, you would find that there's hardly any difference between day 0 when they are sick and then when they recover from day 7 to day 21. There's only a small increase, but there's nothing significant. Okay? And this again made sense to us in the context of tolerance. And then Nancy did some cool, what you call network analysis. And you see here, it's very easy to appreciate. When it's nicely ordered, that means everything is in control. So you see that on day 21, everything is nicely ordered. It looks nice, right? Day 7, you see that it's not as well. And day 0, when you have active malaria, you see that there's distortion in the cytokines. And interesting, you see that in that distortion, the major difference between Accra and Kintampo is this cytokine here called interferon gamma, which is here, okay? And this interferon gamma, again, made sense to us because one of the key mediators of inflammatory responses. So we wanted to take this further. So another PhD student of ours, Collins Misita Muranga, working with Dr. Lucas Amiga Ediko, took this further by using what you call single cell technology. Because of advancement in science, rather than looking at the effect on the person as a whole, or even at the blood as a whole, you can analyze at the single cell level, okay? And that gives you better clarity and better resolution of what is really happening. So like here, you'd see that on the figure on the left, you see that the cell populations are separated out according to different types of cells. So you can basically study what is happening to each type of cell, and you can even study what happens to each individual cell. And so based on that, we found that, children who had what we call subclinical infection, that means that they had parasites, but they did not show symptoms. If you compare those to those who had parasites and were sick, certain inflammatory mediators were increased in those who were sick, and those mediators remained normal in those who had parasites but tolerated them. So again, it confirms the story we are trying to tell, that if you can ignore the parasite, okay, it's hard to do it, but if you can ignore the parasite, it's like a thief has entered your house, just say, go ahead, take whatever you want, and go. All right? He has a knife, so take whatever you want and go. I won't fight you. Okay? So if you have that attitude, you're able to survive malaria pretty well. And we confirm this by looking at what we call different, let's say, categories of genes. And it became very clear that these inflammatory mediators are responsible for the tolerance. And indeed, we found that the interferon response gene module, which I talked about, which is one of the central regulators of inflammatory responses, was the key responsible for what we were seeing. So another interesting thing we found was that, which makes my point about being, ignoring the parasite. So if you look at these figures, you don't have to see what is in there. Just look, the one on your right, I hope it's your right. It's on my right. So the one on the right, you see, or let's say, start from the one on the left. The one on the left, you see a lot of shading. Shading means cellular interactions. That means your cells are interacting with each other. And normally when cells are interacting with each other, that means that they are responding to a crisis, okay? Then on the right, there's hardly any shading. That means the cells are not interacting. The cells are anergic, okay? That means that they are, bored, they are reluctant, or they are aloof, okay? And this again is consistent with the principle that if you can ignore the parasite and not overreact to it, then you have a chance of not developing symptoms. So if we put all this together, Wilson, who is my student, my master's student now, a PhD student in Portugal, we put this together in a paper we published in 2017. And we said that high exposure to malaria parasites creates what we call clinical immunity, or malaria parasite tolerance. And that this is acquired after repeated infections by the parasite. So in this diagram that we provided, if you can see it, you see that in the green lines, that's for people who get frequent malaria. You see that the response progressively diminishes as they get more and more infections of malaria. Whereas those who do not frequently get malaria, so that would be people in Accra, you find that because of the length of time between infections, they seem to respond quite robustly even after having previous exposure. Now, whilst I was preparing for this, one of my friends, Bismarck, came across an interesting paper which really excited me because that paper basically agreed with this theory and went further to show that this actually happens because the cells are reprogrammed through a mechanism called epigenetics. You don't need to worry about it. This just means that the cells are reprogrammed such that they can ignore inflammatory stimulation. And this, they found, happens all the way to the level of the stem cell. Okay, so that got very exciting for us because that meant that it could have an impact on other pathogens apart from malaria because it goes to the stem cell level. So it affects a lot of the cells that are being produced. That means they are already reprogrammed even before they come out. So this tolerance that you have acquired due to your privilege of being bombarded by malaria parasites, you can benefit from this tolerance against other pathogens that have similar mechanisms of disease, such as COVID. And that's where we go next. So we all know in 2019, we're confronted with this disease. Fortunately, the World Health Organization has now declared the pandemic over, so we can sit here and enjoy a lecture without mask, which is good. But we have to recognize that this was a very devastating disease. Almost 770 million people got the disease, and 9.5 million in Africa, and in Ghana, 171,000 cases. I'll come back to these cases later on. In terms of deaths, globally, nearly about 7 million. In Africa, we have about 175,000, and in Ghana, we have just short of 1,500 deaths. If you look at these in terms of the rate of mortality, in other words, if you are using the number of confirmed cases as the denominator, you get the percentages shown below, where it seems like Africa, we even have a higher rate than the rest of the world. But in Ghana, our rate is a little lower than the rest of the world. Now, it is important to bear in mind that these were obtained using the number of cases as the denominator. And as we know mathematics, we would show you that the number of cases was woefully underrepresented, which means that the denominator actually in Africa is much larger than what is on this table, and which means the death rate is much, much smaller than what is on this table. I hope you are following me. Thank you very much. So, just to give you some context, these diagrams that I asked Collins to make for me are just to show you, in terms of context, the complexity of the virus in terms of the genome. So these are the sizes of the genome. So the virus is, let's say, about 800 times smaller in terms of genome complexity than the malaria parasite. Okay? So that is, tells you a lot about how complex a malaria parasite is. But what it means is that even with such a small genome, it has caused so much devastation, and it challenged scientists. In fact, there were times where, as a scientist, I questioned our ability to understand the disease because a lot of the things that were happening did not make any sense to us as scientists. They did not follow normal scientific logic. So with such a small genome, this virus has shown us a level of sophistication that we've never seen before. But what was interesting for us, like I mentioned earlier, is that we noticed that from all the data coming from different parts of the world, what was unique about COVID was that we had production of cytokines, what they call cytokine storm. I'm sure you've heard that before, the cytokine storm. That is very similar to what happens in malaria. In effect, all those cytokines we see in children in Accra is, similar to the cytokine storm that you see in people with COVID. Of course, much, much higher than you see in our areas because we have some tolerance. So then this debate about why, why there were only 170,000 deaths in Africa. So if you look at this map, I hope you can see, you see that in Africa, sub-Saharan Africa looks very clear, okay? Note that the darker the color, the more deaths, okay? And this is corrected per 100,000 of the population. So you see that we were really doing well when you look at the number of deaths. And this sort of challenged the pre-pandemic predictions where there was, a lot of gloom and doom about the continent. But if you look at the waves, there were pandemic waves, as we remember, and you see that the waves are shown here again. My student put this up for me. You'd see that Africa, our waves sort of lagged a little bit behind the global waves, and Ghana, our waves also lagged a little bit behind those of Africa, which was a good thing. But the waves did come, and we did get sick, and I'll show you. Sorry, we did get infected. Now, one of the theories for why we didn't have a lot of deaths was that there was a lot of excess deaths, what we call excess deaths. So they're saying that, several millions of deaths were missed on the continent. We didn't count them. We just didn't count. They just died. They died, and we just didn't see. So this is one of such studies that makes that case about excess deaths. And in the case of Ghana, I know you can't see it well, but they tried to say that our deaths were at least 30 times more than we reported. So in other words, they're saying that about 40,000 people died, and we didn't know. Okay. So when I saw that, I was not happy. So myself and some friends, we responded to the publication. So you see here that we rebutted the publication and said that we don't think that that analysis makes sense. So anyway, we don't believe that 40,000 people died in Ghana we didn't see. It's not possible. Okay? Because I make the case that COVID was in Accra a lot before it even went to the villages. How do you hide dead bodies in Accra? In fact, it's more expensive to bury somebody, than to just declare them and give them to the COVID people to go and bury. So why would you hide 40,000 bodies in Accra? So I didn't believe in that, and we made that case. There's also the theory about age, that Africa will have a younger population, which is a good point. But studies have shown that even if you control for age, still Africa we did better in terms of not having severe disease and not dying. How about genetic factors? Yes, it's also possible that being black has some advantages. So maybe we had some genes that protected us. Now, the problem with that theory is that our brothers and sisters who lived in the US and UK and Europe, they had no advantage when it comes to COVID. The data shows that black people were as vulnerable as white people. Okay, so that theory cannot be sustained. That the virus was weakened by the hot weather, which also is tempting to think about. But when you look at places like India, okay, where it's quite hot. If you've been to India, it's quite hot there. But the virus caused a lot of devastation there. And then other very warm countries. Then there was the theory, which a lot of scientists subscribe to, that maybe there's cross-protection. That means because we've been exposed to so many other viruses, especially cold viruses, that maybe that immunity that we've developed is helping us to resist, the virus. But our studies have shown that that's not really the case, because if that were the case, you would find that the levels of viruses in people who get infected here will be low because the antibodies will control the virus, but that was not the case. People had viruses, all right, loads of viruses. If you ask our friends in Uguchi, they had people with, CT values in the teens, which means there's a lot of viruses, okay? And so it wasn't a question of controlling the viruses. And then more broadly, maybe a robust immune system that has been built by our bombardment by many pathogens, all the wache and the roadside, omutuo that we eat and all the pathogens that were exposed in that process. Maybe that protected us. Well, again, that would make sense, but if you go to the slums in South Africa and India and all that, they have they can challenge us for germs, gem for gem. Eh? So how come they were not protected? So that theory too cannot really survive. And then we had more effective control measures. This is something the politicians like a lot, that they were very successful, okay, very effective in controlling the virus. And I will show you that it was not really the case, okay? But credit where it's due, our government in particular, they did quite a bit with the president himself showing leadership. So they did what they could do. We just didn't listen to them. We still went and had our funerals with our, mask on the chin and eating chicken and talking to each other, whispering to each other, So we're spreading the virus pretty good. So it's not a question of not spreading the virus. We were spreading it very well, okay? So it's not true. Better patient management. Again, I think there's some truth to this. I think our doctors did really well. Those cases that were severe, I think they saved most of them, which was good. And I think that if there's any credit at all, the health facilities did very well. But again, yeah. But again, that's not sufficient to explain what we're seeing, because how many people had severe disease in the first place? If you look at the percentage, it's not a lot. So that's not really the case. Then there's divine intervention, yeah? Yes, so God loves us, huh? More than the others. But again, there's some truth to this, because those of us who believe that malaria helped us, it's God that made us have malaria. So you can make a case for it, okay? So anyway, if you look at all these, none of them are sustainable, okay? Each of them can be easily knocked down, okay? So what I'm offering today is a unifying hypothesis, something that takes all these into account, including the divine intervention. Because look at this map. This is the map of malaria cases in the world in 2020, when COVID was at its peak. What do you see? Do you remember the COVID map? Okay. Now, look at them side by side. Isn't it nice? Isn't it beautiful? Where you see no COVID deaths, that's where malaria is intense. Just look at it. You can superimpose them. Okay? So this was very interesting for us, because this is not a coincidence. Okay? So because of that, we dug back into our theories of tolerance to inflammation, knowing that cytokines, or the cytokine storm, is also central to the way COVID works, okay? So at WAGBIP, as you know, we did our part in terms of the COVID response. We did a lot of studies, just like with malaria, we did several different types of studies. You know that we did a lot of sequencing, and then we did some seroprevalence work. Here I've shown some of our key leaders when it comes to COVID. Peter was our main virologist, Yao, immunologist. Joyce mans our sequencing system, and Collins is a gem. He's a bioinformatician. He is the one who cranks the data, okay? This guy is a smart guy. So these are the people. In addition to many, many people, but you know, these are some of the key people who allowed us to do what we did as WACDIP, okay? And some of the contributions that they did, you know, we leveraged our existing capacity, okay? When COVID struck, we were busy trying to sequence malaria parasites, and we put that aside and redirected the resources and the talent to working on COVID. And that is because we had the capacity to mobilize resources. We did not wait for the government to give us money to start sequencing parasites. We redirected the resources we already had to sequence malaria parasites to start to sequence COVID-19 viruses, okay? And we also redirected a lot of our human and material resources towards this. And we had a lot of collaboration with many, many institutions across the country. Noguchi, one of them, KCCR, and many, many, many laboratories and hospitals around the country. The infectious disease center, as well as Ghana East, these were all very, very cooperative in terms of working with us to get patient samples to test and to try to understand this disease. So if you look here, you look at samples we got from across the country. The map shows you how many samples we got from each location across the country. And with this, we did a lot of sequencing. We did it monthly, so you could track by region and by month. So this is by region. You can track which variants were in each region at any particular time. And this is by month. You can track what is happening in terms of the types of variants that are in, that are prevailing. And if you look here, if you look at the major variants of concern, you see, I think I went too far, sorry. So you see that the major variants of concern, you have the alpha, the beta, the delta, all of them took their turns to dominate. So you see these waves, okay? So these are the waves that we had with different viruses coming and having their turn to infect us and go. But you see that it was interesting that each of these waves were very sharp peaks. They rise and within 2-3 weeks they come down. And you remember that those times we have a wave and there's panic, within 2 weeks it's gone, okay? And that is partly because the virus was spreading fast and we were getting some kind of herd immunity within a few weeks because all the people who were able to transmit the virus did, okay? So we all got the virus quickly, got antibodies, and then we were done with that variant. We're waiting for the next one, okay? Anyway, just as a matter of interest, currently these are the variants that we have in the country. The XBB are dominating currently. But for the story today, I'm going to focus a little more on what we call the seroprevalence study. So because we knew that across Africa, not only Ghana, the testing system was based on people who actually show up and they are not feeling well, or people who wanted to travel, okay? There was no mass testing where in other countries they will distribute test kits and you test yourself and report and all that. So we realized that there was the need to find out what was actually happening in the population because the data that was coming was mainly those who voluntarily test or those who had to travel, okay? The market women and truck drivers, they didn't get a chance to be tested. So what we did was to test them for antibodies. So we did a big study to test for antibodies, okay? Antibodies show that you've had the infection before, either, the week before or a few weeks before, all right? That's when you have antibodies, that's what it means. You've been infected before and recently. Okay, so we targeted what we call the economically active population. So we went to public places, went to workplaces, churches and mosques and so on and so forth. And we did a lot of this together with SHAG, okay? The Christian Health Association of Ghana. Okay, they have so many facilities in some of the most remote areas. So working with Ghana Health facilities as well as SHAG facilities, we were able to cover many areas. And these are some of our team members. A lot of this work was coordinated by Gloria and Daniel Odromensa. You see them here. in different parts of the country, interacting with people and taking samples. So in addition to doing this in Ghana, we also had funding from the Rockefeller Foundation to extend this to other West African countries. So we chose Burkina Faso and Nigeria. So you see in these maps all the places that we covered in Burkina Faso, Ghana, and Nigeria. So overall, we tested about 20,000 people in these 3 countries. So when I show you the data, there's no doubt about what you are seeing. 20,000 people, that's not a fluke, okay? So anyway, what you saw was that once we had those waves, there was a lot of infection. So you'd see here that, for example, in Burkina Faso, between June 2021 to November 2021, the average was about a little over 20%. In Ghana, around the same period was about 45%. But once we had Omicron, many of these places just went through the roof. And in Ghana, we were hitting above 80%. And in the graph in the middle, you'll see that even if you look at it month by month, you see how the dynamics work. And as soon as Omicron came, we basically all got infected, okay? And I want to give credit to our data manager, Francis, who, had to contend with, data from 3 different countries coming in at midnight and all kinds of hours. And he had to manage all this data and make sense out of it for us. So let me just narrow in a little bit to Ghana. So you see here, I've just zoomed in for you to see what happens in Ghana in 3 periods. You see that after each wave, more and more people got infected, okay? So the idea that we control the virus, it's just not borne out by the truth, by the fact, because at some point, 80% of the people we tested had antibodies, okay? And then if you look at Greater Accra in particular, you see the same trend basically, that by the time we had Omicron, about 80% of us had the virus, okay? Now, what was interesting for us is that as part of the questionnaires we used to recruit people for the study, we asked them whether they knew that they had COVID. In other words, did they have a test? And you see that that red part of the pie, which is about 90% across the 3 countries, they never took a test, so they did not know that they ever had COVID. And almost all of them didn't even know because they were not sick. A few drivers said, oh, they had some small cold, but it was nothing, They went to work all right. They never missed a day of work. Okay? So this was, again, fascinating to us because it confirms that we were quite robust in the face of this virus. We got the virus all right, but just ignored it, okay? And this ignore takes us back to the tolerance that we learned from malaria. How do you ignore a pathogen? It's malaria that taught us how to ignore pathogens. So one of our PhD students, Kessie, working with Peter Kwashi, they took the samples that we got from all these hospitals and then those that were testing for travel and others, and then, contact tracing. So normally, most of the asymptomatic people, you find them when you test their relatives who are sick. So, because ordinarily they wouldn't even be tested because they are not sick. So you find the asymptomatics from those, and people who are traveling, and then they find out that they have COVID, so they can't travel. So anyway, we had 2 groups of patients, those who had the virus but didn't know, were not sick, and those who had the virus and were sick and in the hospital, okay? So, it's slow, but anyway, this may be too small for you to see, but what I'm showing is that in the red bars, you see those who had symptoms. So these are levels of various cytokines, pro-inflammatory cytokines. You see that the red bars show those who had symptoms or symptomatic, and the green bars are those that were asymptomatic. And you see that across the board, those who had symptoms had way more cytokines. And more interesting, you see that those who did not have symptoms seem not to make any cytokines at all. They ignored the virus. they did not make any cytokines at all. If you look, most of the green bars are flat. Okay? So this was very fascinating for us. And then we wanted to find out, did this have to do with how much malaria they had? So we looked at their levels of malaria-specific antibodies. So these are some malaria antigens that we had. We just tested them for antibodies. So you see that, again, it is very generally true that those who were asymptomatic, in other words, those who were able to ignore the virus, had more previous exposure to malaria. Okay? And then we even took this further. So Kessie took cells from some of these people who were infected, asymptomatic and symptomatic, and cultured the cells and directly stimulated them with malaria parasites or COVID-19 antigens, okay? This is to directly find out whether they will respond. And you see here again that if you look, symptomatics are in red and asymptomatics are in green. You see that for the most part, the asymptomatics ignored the antigens, okay? So this is, we believe, the basis for them being able to ignore the virus. So, how many minutes do I have? All right. So anyway, just to summarize, these studies we did looking at antibodies to COVID, the test kit we're using, it has a sensitivity of only about 80%. What that means is that we're not even picking up all the cases, all the people who had been exposed, because we're only picking up about 80% of them. So if we're picking up 100%, that means there will even be more. So it just tells you that COVID, the virus, we all had it. Okay, we all had it. All right. And this suggests that the estimates that are provided, and I'm not trying to say that anybody is deceiving you, because in Africa we don't have enough resources to be testing everybody. So they test those who are sick, those who need to test, or those who can pay when they are traveling. So it makes sense. I'm not criticizing the approach to testing, but the reality is that we are missing the majority of the people who were infected. And that's fine because they were not sick. Anyway, and this was true across other West African countries, as you saw, in both Burkina Faso and in Nigeria. So we basically think that there was no real cytokine storm in us when we had COVID infection. Maybe we had a trickle or a drizzle, right? And that is how we managed to overcome, okay? Anyway, and if you circle back, that tells you that our ability to not respond to the inflammatory stimulation is what took us there. So we're now into the last part, so I hope I have 10 or 15 minutes. All right, so the last part I'm going to talk about capacity building. And one of the bad and good of COVID is that the good is that it showed that African scientists were not as useless as many people thought. In fact, some of us, the media now loved us, and they were calling us around the clock, you know. When we used to do science and we tried to put it out there in the media, they ignored us. They thought it was boring. But now they were really interested in what we're doing. But it showed that African science had a heartbeat, okay? Because we're able to sequence the virus just like others did. We're able to test the virus as others did. We just didn't have enough resources to test everybody, okay? And we're able to understand the virus like I've made you understand today, like everybody is doing, okay? So African science has a heartbeat. However, we had to beg for vaccines. We had to wait for vaccines. We were lucky that we didn't need them after all, but we had to wait. Others had to take second, third jabs before we got one. That is a warning for us, that we need to do more in science. We need to be ready next time. Okay? So The good is that we are better than many people thought. The bad is that we overperformed or we over-delivered based on the resources that we had. And so we need more resources. We need more support, okay? But let's talk about the progress that has been made. For a long time, science has been ignored on the continent. Indeed, about 15 years ago, heads of state of Africa met and had a nice party and swore that each of them would spend at least 1% of GDP to support science and research. As we speak, 5 countries have done it. Ghana is not one of them. Okay? Ghana, we are about 0.4% or something like that. Okay? Which is not bad. Others are like 0.1. But it tells you that even the minimum commitment that they made, they couldn't meet. Okay? So the reason we've made progress is not directly due to government supporting, but I'll tell you that they've done, or they were tricked to support us a little bit. There have been a number of funding initiatives that have been targeted at building capacity on the continent. One of them was the World Bank African Centers of Excellence. And this one was a very clever strategy. So the World Bank decided that they would make a call for proposals to establish centers of excellence. They will make it a competitive process, let scientists compete. But before you enter the competition, your government has to agree that if you win, they will give you the money, but they will add it to your loan stock. It was clever, wasn't it? Because each of us who won got $8 million to do science, to support young people to do science, and all of you here would pay for it. So yes, our governments have done something, but Professor Duwejo is here. He was leading this when it came. And, you know, ordinarily, I don't think our governments would have committed $8 million to build WACBIP or WACI, okay? They wouldn't do it. They may want to, but there are other priorities, right? But the World Bank got them to do it. So it was a clever strategy. But anyway, many scientists benefited from this, including us. We got one of those $8 million grants. That's how we started WACBIP. There was also Deltas, which is another initiative that at the time was hosted by the African Academy of Sciences, funded by the Wellcome Trust and other partners, including DFID. And they put $100 million on the line, again, asked scientists to compete and win some of these grants. And we did compete, and we won one of those grants. Luckily, after a cut in funding due to COVID, they've resumed, and they did another round of competition, which we won one grant again. So we are part of the Deltas Phase 2. There's also been the H3 Africa initiative, which is a genomics or genetics, human genetics focused initiative funded by the NIH of the US and the Wellcome Trust of the UK. And this has also supported African scientists across the continent to build capacity for genetics research to understand non-communicable diseases better. And WACBIP, with other partners, we also assess some of these resources to build capacity for genetics research. And then, just the last one I want to mention is that the UK government made a strategic decision a few years ago to redirect some of their, what they call overseas funding, or foreign overseas investment, whatever they call it. But they directed these resources, 1.5 billion of it, pounds, towards grants to African UK collaborations. And this also made a significant impact to WACBIP and to many African institutions that were able to compete and get some of these resources. So anyway, back to WACBIP. So over here in Ghana, at the time that some of these initiatives were going on, I was the head of the Department of Biochemistry. Professor Koram was the director of Noguchi, and the World Bank call came, and we saw it as an opportunity to access some of these resources. On my side, at the Department of Biochemistry, it was a department that was deprived of resources for a long time. Before I went to the US, we had, barely nothing to work with. When I came back, we still had barely nothing to work with. And so this was an opportunity for us to make a difference to the department. And moreover, there were a lot of young people in the department. In fact, I thought I was young, but many of them were younger than me. So I could gather them together and let them work. And they had a lot of energy. There was what I call restlessness. They were restless because of the lack of resources to do good quality science like what they did and wherever they came from. So working together with friends from Noguchi and our University of Ghana Computing Systems, and supported by some of our foreign partners, including the American Society for Cell Biology, we put together the proposal to set up WACBIP here at the University of Ghana. And like I mentioned, we were fortunate enough for the government of Ghana to commit to give us, or let us take the $8 million, and they would charge all of you to pay for it. So that's how we got started. All right, so I've outlined all the different mandates that we've had, the schemes that we've worked with. We're also an Arua vaccine development hub, with something that came in the wake of the COVID. But the vision that we had for the center was to establish a major hub for biomedical research training and the development of homegrown, globally competitive African science leaders. So we were really focused on training new leaders, finding young people wherever they are, the best young scientists, and training them. And this is because we think that to get the Africa we want, we need to provide opportunities across the pipeline, right from undergraduate to PhD level. And that's what we've done. We provided training for scientists right after undergrad all the way to PhD level and postdoc. We also believe that we needed to create an environment where high quality research can be done and where proper science leaders can develop. We wanted to ensure that there was equity and there was diversity and inclusion to make sure that nobody was disadvantaged. And indeed, people who were disadvantaged were given a chance to also get their opportunity. We tried to give our trainees a set of skills that are unique to the continent. Those of us who studied abroad know that doing science in Africa is not the same as doing science in the US or the UK. When I was in the US, if I did an experiment, it didn't work, I just throw it in the trash and order reagents online, and the next morning when I come, the reagents will be waiting for me, and I will go and repeat the experiment. No sweat, right? Here, when your experiment doesn't work, you have to go through procurement for about 3 months before the VC will sign. And then it will take you 6 months for the reagents to arrive. By that time, your friends in the UK and the USA have done 50 experiments. That's why we can't compete, ladies and gentlemen. That's why we can't compete. So, anyway, in order to do science here and thrive like we have done, you have to adjust and have a certain mindset and a certain level of planning and discipline. And that's what we try to teach our trainees, to be able to let them survive here, okay? And we also hope that training them together, they will create bonds that will last forever, and that they would work together even after completing University of Ghana. And then, finally, research is about innovation and supporting public health. And so we used research as the tool to train people, and that is the vision that we had for the center. And this is how we thought we could contribute to the Africa that we want. So let me quickly tell you how we've done. In terms of raising funds, one of the things we pride ourselves in is to be globally competitive, compete for some of the most competitive grants in the world. So we build a grants-minded culture. We build a work ethic where everybody tried to be independent and to write grants and to bring money to the institution. So over the period, we have helped bring $52 million to this institution. Of that, about 42 million of it came directly to us. Others went to other units where we have some of our collaborators and faculty. But the one that came to us, we were lead institution in about 3/4 of those grants, okay? Which shows that we lead. We take the initiative and we apply for grants and we compete for them. And that's how we build this grantsmanship culture. And we want to emphasize that the majority of the money we brought in was used to give scholarships or fellowships to students and to buy equipment and to put up a building. We invested it right back into the system. So with the funding, we've created a pipeline for students to access grant support right from graduate internships, who are basically national service people, up to the time that they can form their own research groups. So at every level, there is money that they can compete for and support themselves. And this is the environment that we've created at WACBIP. In order to do this, we had to create an environment that is world-class, that can support world-class science. And like you saw in the video, Yao was, in the UK, and he was looking for an opportunity to come home. So when he met me and I invited him to come over, he came over and saw the facilities that we had put in place, the culture that we had put in place, and he said, I can move from the UK and come here and do science. Okay, and that's how he came back. We have also built partnerships extensively. We have a very inclusive culture at WACBIP. Everybody's friend is our general friend. So all our collaborators are all our common collaborators. I welcomed the collaborators of all the faculty who contribute, and we treat them very well. And so they are all committed to supporting us. So we've built a broad network of faculty members from across the world, and that has helped us to train the students. Then the key to our success is to attract the best young people. So for every money we want to give out, we go through a competitive process. We open applications and everybody from any African country can apply. And we go through a selective process and we choose the best and we award them the fellowships. And so in doing that, we've attracted some of the best scientists in the world to come to the center, young scientists. Young scientists from across the African continent. And also part of the work I was doing, like Yao told his stories, whenever I go overseas for meetings and for conferences, and I talk about WACBIP, I always invite any Africans in there to come and talk to me so that we can encourage them to come home. And we've brought a lot of them home. In this picture, you'd see on the right, all those people, we help them to come back home. We help them to come back home. Just some numbers. So far, we've given support to 350 young African scientists, 202 at the master's level, 107 at the PhD level, and 41 at the postdoctoral level. You see the breakdown in male, female over there. This is a map showing where all the fellows have come from. They've come from mostly West Africa, but they come from far and near, as far as in Southern Africa. We have somebody from Botswana who did some of the work that I showed you. And so we are saying that all African scientists have an opportunity. If you are one of the best, you have a chance to come to WACBIP and develop your talent. Now, what has happened to our graduates that have come out so far? We like to monitor and evaluate. So for master's graduates, the majority of them have gone on to do further graduate studies. That means they've gone into a PhD program and so on and so forth, which is good, which means that we're building research capacity. It means that we're achieving our goals. Some of them have gone into industry, to the public health sector, and to research institutions. In terms of retaining them on the continent, about half of them have remained on the continent. And that is not bad, considering that these are master's students, and after master's, many of them would want to go outside and do PhD, but we hope that they will come back. For the PhD, In fact, for the PhD, 86% of them have remained in academia, okay, as you can see here. Few have gone into industry and the public health. And for the PhD, many more have remained on the continent. About 80% have remained on the continent, which is very good for us. For the postdoc, which is basically the end of the line in terms of our training, from here they become independent scientists. You would see that 96% have remained in academia. And more importantly, I think my graph, some of the labels are not showing, but more importantly, about 90% of them have remained on the continent. The World Bank did a survey to look at the impact of the centers that they established. And I just want to highlight two things. 79% of industry stakeholders who had employed or worked with our graduates said that they had a unique set of skills and knowledge of the latest technologies. Okay? So that is validating the approach we're using. 88% said that they had very relevant skills to industry. So the idea of industry saying that we are not producing for them, we are. All right. As an academic institution, we are measured by publications as well. We have produced more than 350 publications from the center since we started. And we make it a point to let our students and postdocs lead. So you'd find that more than 80% of these publications, a student or a postdoc is the lead author. And this is how we build African science capacity. Majority of these have been in malaria because that was our major area of research. But you see that COVID and other diseases have been covered effectively in our output. I want to highlight one of our own, Dr. Awandare, who you saw in the video. He's started a biotech company. One of the challenges we have is that we have to create opportunities for the scientists that we train. We cannot be training scientists for them to be in academia alone. We need to create opportunities in industry for highly skilled scientists. Most of the industries that we have, when you go there, they don't need a PhD scientist, or they don't want a PhD scientist, because they don't want to do any complex research. They just want to maybe make drugs or make some, what do you call it, Cerelac or whatever. They just want to produce based on a set formula. So research and innovation is not something they prioritize because it is expensive. It takes long-term investment to start to get rewards. Okay? So in this crisis, some of the scientists have to be bold and start businesses and create opportunities. And Yao has taken that initiative and started a business. It is part of the impact we want to make. We want to encourage more of our scientists to start businesses and be entrepreneurial and create jobs for other scientists. And this is how we build the Africa that we want. All right, to sum up, we think we have done well in our space, but we are looking at how we can spread the impact. Now we have a lot of our graduates across the continent, and so we are using several networks with support from FCDO, Wellcome Trust, and others. We are creating networks to train other scientists in their institutions, creating different nuclei that can grow and become like WACDIP in Burkina Faso or in Cameroon, okay, or in some remote areas of Nigeria. This is what we are trying to do now, to use networks to increase the impact. And one of those networks, like I mentioned, we're getting support from Arua to do a vaccine development network. I'm going to finish with this slide, and then I'll do conclusion. Before COVID, we advertised for PhD positions. We had 10 PhD positions to give. We had 518 applications from across the continent. You can see where they all came from. Nigeria is one of our popular places. They had more applications than Ghana, so that tells you how enthusiastic they are. But what you see here is we have started a revolution, revision, and the young people are responding. They want to be part of it. So can we cope? How do we continue to provide opportunities? How do we sustain the work that we've done? Would governments step up and put research into science? Funds into research. Okay? Would we have a proper private sector that is employing PhD scientists? Would the government require all pharmaceutical companies to have a research unit headed by at least 2 or 3 PhD scientists? It should be compulsory. This is how we innovate. This is how we can make our own drugs and our own vaccines. We need that kind of policy. So, ladies and gentlemen, I'm done. I'm going to give you the conclusions. So, I believe, or I hope, I've convinced you that malaria is not such a curse. That after repeated exposure to malaria, we learn how to tolerate malaria, or we learn how to ignore the parasite. And that the way we learn how to ignore the parasite, we use the same knowledge to ignore the COVID virus. And that's why we didn't die. That's why there were no dead bodies on the streets. That's why our hospitals did not collapse. Because God was with us. But next time, God may not be with us. So we need to build scientific capacity. We need to support institutions such as WACBIP, WACI, Nuguchi, KCCR. I mean, all these institutions are doing great science. Let's support them. Let's build capacity. Let's train more people. Let's be ready to make our own vaccine next time. I thank you very much. Thank you very much. Thank you very much. I want to say a few thank yous. That doesn't count in the time. So I think that whatever I told you today, I told you why all the other theories don't work, and I told you why my theory will work. So you can call that the Awandare hypothesis as you go home. Anyway, so I want to thank our funders. I've told you how much we've done, starting with government support, but, you know, many funders saw what we're doing and liked it and supported us. And that has allowed us to help so many students and to build capacity here at the University of Ghana. So we want to thank all the funders from across the world who have supported our work. We want to thank the steady participants. Science can be annoying to steady participants. You take their blood, you poke things in their nose, and so on and so forth. So I want to thank them for their patience and their tolerance and for helping us to do science. So I want to thank them very much. I want to thank all the students, we call them WACBIP fellows, all those who competed and got support from WACBIP and got a training at WACBIP. We thank you for believing in the vision. Okay? We thank you for believing the vision and imbibing the training that we gave you. And we hope that you'll be successful wherever you go. I want to thank the contributing faculty. Because of the high numbers of students we were training, or that we are training, there's a lot of burden on the faculty. So we really want to appreciate our faculty for, you know, sitting through seminars the whole day, comprehensive exam the whole day. You know, if you have many PhD students, it's a blessing, but it's also a lot of work. So we want to acknowledge our many faculty across the university. We have something called a WACBIP machine. You see, on my door, I have a label there. If you look down, I don't know whether you can see it well. It says, no excuses, just get it done. That's the motto of WACBEP. We have a culture, a work ethic that says, just get it done. Don't come and explain. It's easier to just do it. And that is the ethic we teach to our people and all our students. And because of that, over the years, we have built a system that is very robust, that is competent, that shows that Africans can manage affairs in a very efficient manner, and that can deliver results, and that can compete globally. And that's what we call the WACBEP machine. This is, leaders all the way down to cleaners and drivers. Everybody knows what they need to do. They know that there's a certain standard that we need to meet at WACBEP. And so I want to thank everybody for doing their part to keep the machine rolling. Thank you very much. Over the course of my career, I've had a lot of support and mentorship and leadership at different times. And I want to acknowledge many, many people. I'm sure I left some out, but there are many, many people who have played significant roles at different times, and I've put their names here, starting from all the people who taught me biochemistry and tolerated my troublesome self those days, and even had the audacity to invite me to come and join the department. I thank them very much. In the broader university, many people have supported my work and facilitated things for me. Prof. Akamori gave me the opportunity to start to do malaria work. Prof. Eric Dankwa, I've learned a lot from running a center. Prof. Yantia Mwabedu, teaching us how to build institutions. Nobody has built this institution more than Yantia Mwabedu, and we appreciate that. I've already mentioned Prof. Kuram. Prof. Enezaite was the VC at the time, and I used to call him Mr. Research Intensive, because when I came back and I was trying to be research intensive, he was speaking the language that I liked, so it really inspired some of the work that we did, because he wanted the university to be research intensive, and that really had an impact on the type of things I wanted to do. There are so many other people who have listed, who have supported us, including our current VC, who has been very supportive of us. We thank you very much. So many international collaborators, I can't mention all of them, but they are all very appreciated for supporting our work and doing great science with us and publishing with us and training our students. We thank you very much. I'll end with my family. My parents are here. They sacrificed a lot to give us an education. My siblings are here. We are all very close and we support each other. And I'm very grateful to have a family like that. I want to thank my wife. You see, I used to be handsome before. So we've been married 18 years. We are blessed with 3 kids. And, he left his family and moved to Ghana with me so that I can do what I'm doing. So I thank you very much. I have other family members. We have a very big family, and we are all very close, and we love each other. And I'm showing you just some pictures from the family. I have my aunties and uncles here, many of them, and we are all very close, and we love each other, and they support us so much. My life has been impacted a lot by my friends. If you do a stressful job like I do, you need time to de-stress. And I have a lot of friends that I've had since childhood, some through church, through Notre Dame, where I went to school. I'm sure they are here. Notre Dame, you're here. And then to Presec, Ɔdadeɛ, you're here. And then so many people in UG and other social networks. We have basketball. We play basketball together. I have basketball people here. And then the Ghana's faithful. Where's Frank Amfo? The VC's husband is part of the long-suffering Arsenal fans. Next year we'll win the league. So, yeah, and I want to remember one of my best friends who we lost last year. Skorken. Thank you.
Thank you very much as well, Prof. Awandare. We are so grateful to you for unpacking such important issues on a topic so crucial to our health. Thank you. I think your data on COVID-19 reminded me of my own experience. I remember I used to be so meticulous about observing the protocols, so I thought that I won't be beaten down by COVID-19. Then I had cough and cold, and I became apprehensive. Then I went to the hospital for COVID test. They told me that in 3 days I'll receive the results. I waited 3 days, no show. 1 week, no show. Then I became so afraid, I started talking about it. Then a friend of mine said, "Don't worry, you didn't test positive. If you did, they would have come chasing you like a thief." We thank you so much for revealing so much about COVID-19 and malaria to us. Please let's give him another round of applause. On a lighter note, Prof, please will you employ me as the treasurer of your congregation? I'll come for the name of our chair so that I put it in my application to you. Madam Chair, distinguished ladies and gentlemen, before we proceed, please permit me to acknowledge some personalities who have joined us today. We have with us our Chancellor, Mrs. Mary Chinwe-Hesse, and we have some of our former Vice Chancellors here, Professor C.N.B. Tego and Professor Ivan Adai-Mensah. We also have some of our former registrars with us, Mr. A.T. Kunu and Mrs. Mercy Hazel Ashia. We are also privileged to be joined by the IGP, I think he's been mentioned already, Dr. George Ekufu-Dampare, with a strong team from the Ghana Police Service. In addition, we have Dr. Mohammed Ibn Chambers, African Union High Representative on Silencing Guns. And then also we have Professor John Bafo Ajimandria, CEO of the John Ejekum Kufuor Foundation. We also have with us the chairman of the UG Alumni Association, Ms. Doris Ansa, and I know that some alumni council members are also here with us. We thank you all. I'll pause here and we'll move on. As we go on, we will get to know some more people who are here with us this evening. At this point, we are going to invite the Ghana Dance Ensemble for the musical interlude. And usually, for an occasion like this, the Ghana Dance Ensemble has a piece of information for us. The dance they are to perform is called the Bima dance. This is a recreational dance of the Grushi and Frafra people of Upper East region. The dance is playful in nature, where young men and women playfully interact with each other through movements. For this inaugural lecture, this dance was selected to reflect the ethnic background of Prof. Awandare. It is said all work and no play makes Prof. Awandare a dull professor. Hence, this dance is selected to balance the work and life of this hardworking and illustrious academic and family person. For those present at this lecture, remember to intersperse hard work with a spot of playful activity to reduce stress in order to stay mentally alert and physically strong. Distinguished ladies and gentlemen, the Bima dance. Please let's give another round of applause to Dr. Aristis Hago and his team of performers. Dr. Aristis Hago is with the School of Performing Arts. Thank you. And I'd also like to acknowledge Mr. Mutala Mohammed Karim, the one who did the beautiful Lunga appellation prior to the lecture. Please let's give him a round of applause. Madam Chair and Vice Chancellor, it's now time for presentations. And so I'm going to call out some groups and individuals, and then you come up here with your present for our lecturer for this evening. The first on my list is the College of Basic and Applied Sciences, Professor Awandare comes from the College of Basic and Applied Sciences, and it actually starts from the School of Biological Sciences, which is situated at the College of Basic and Applied Sciences. And so I'll first of all call the College of Basic and Applied Sciences and also ask the School of Biological Sciences to get ready. School of Biological Sciences, please get ready. School of Biological Sciences. Okay, the School of Physical and Mathematical Sciences should also be on its way. School of Physical and Mathematical Sciences. That's a sister school in the college. Office of the Pro-Vice Chancellor for Academic and Student Affairs. While the West African Center for Cell Biology and of Infectious Pathogens gets ready, WACBIP, please get ready. You will come after the Office of the Pro-Vice Chancellor. Noguchi Memorial Institute for Medical Research, after WACBIP. Noguchi Memorial Institute, please be on your way. Office of the Dean of Student Affairs, please be on your way. Office of the Dean of Student Affairs. While the UG Pan-African Doctoral Academy also gets ready. UG PADA, please get ready. The Student Financial Aid Office, please get ready. Student Financial Aid Office. After the Student Financial Aid Office, we'll have the Academic Quality Assurance Unit. the Academic Quality Assurance Unit, okay, please let's have Africa-based gender tech platform for gender-responsive malaria advocacy and policy. While the heads of halls get ready. Heads of halls, led by their chairperson, Dr. Margaret Amankwa-Apuku. The Department of Biochemistry, please get ready. Department of Biochemistry, Cell and Molecular Biology. Careers and Counseling Center, please get ready. UG Careers and Counseling Center. Academic Quality Assurance, I mention you again to follow Careers and Counseling Center. Academic Quality Assurance Unit. International Programs Office should get ready. International Programs Office. While waiting for the International Programs Office, CK Tedam University of Technology and Applied Sciences should get ready. CK Tedam. Lifestyle Basketball Club should also get ready. Lifestyle Basketball Club. Baobab Group, please get ready. I have to get ready to join this team. Baobab group, please get ready. Baobab group. Then Sosiga community. Sosiga community. Prof will play the ball in our church. After Sosiga community, we'll have UG undergraduate biochemistry class of 1998. UG undergraduate biochemistry class of 1998. Please get ready. Biochemistry class of 1998. Biochemistry class of 1998. Then after that, we'll have Awandare Malaria Lab. Awandare Malaria Lab. After them, we move to the old boys. And so Notre Dame old boys should get ready. Notre Dame old boys, get ready. Okay. Presec old boys should get ready. Presec old boys, please get ready. we wait for the Presec Old Boys, please let me chip in this. Academic Affairs Directorate, if you are ready, please come up. Academic Affairs Directorate. And the College of Health Sciences should get ready. College of Health Sciences, please get ready. And Fellows of Commonwealth Hall, please get ready. Fellows of Commonwealth Hall. After them, we will have Presec Old Boys. Presec Old Boys, please be on your way. So I think I was wrong in saying Presec Old Boys, Presec Old Students. I remember in those days the sixth form used to have both male and female. I have marked all those who were singing well and those who were not singing well. I'll send the results to the headmaster. We now want to move to the family of Professor Awandare, and I'll start by inviting the aunt of Prof. Awandare, Aunt Regina Ataya, and her husband, Mr. Emmanuel Yalboachi, to make their presentation. please get ready to make your presentation. Prof. Awandare's aunt Ataya and her husband. Prof. Awandare's parents and siblings should get ready. Prof. Awandare's siblings and parents. The last but not least on my list, we have Prof. Awandare's wife and children. Thank you very much. Please take your seat, Prof. Awandare. We are grateful to you all for your presentations. Ladies and gentlemen, before we take the chairperson's closing remarks, I'm happy to inform you that we were also joined by Dr. Samuel Kordonko, the president of the Pharmaceutical Society of Ghana. It is now time to welcome our chairperson, Professor Nanaba Appiah-Ampho, for her closing remarks.
Thank you, Director of Public Affairs. It's been a long evening, but one worth it. Gordon, I hope that after this long evening, you still have a lot of energy, because what I saw here, Anyway, I'm one proud Vice Chancellor this evening. I am proud because we've seen right here the high quality scientific work being done right here at the University of Ghana. You've seen it for yourself. If any other university in this country tell you they are the best, well, the evidence is there to show. We have the talent. All that we need is more resources. And Professor Awandare has this evening made the case for African science. He's shown us that we do have the capability. Once we have more resources, we'll be able to do more. I hope that this evening, African leaders will be more committed to their earlier commitments of devoting 1% of GDP for African science. Prof. Awandare has also, I hope, made a case, and I hope that we have some parliamentarians here this evening, made a case for the procurement process, the sometimes cumbersome and lengthy public procurement process that we have. I'm sure that when the law was being made, they didn't have scientists on board and they weren't thinking about scientific research. I have to wait for 3 months to sign those contracts because I don't want to go to jail. But we do want to work to progress, and I'm sure that very soon we'll be lobbying some parliamentarians to support us to make the case so that we can have procurement for scientific research more rapidly done. Now, when I come for such lectures, I always pick up lessons. And so this evening, I want to attempt to give a summary of what he presented, because I cannot do it better than he did. But what are the lessons that I picked? And these are what I share with you as we close. The first thing, rather surprising, is that malaria is a good thing after all. Who would have thought? Now, I'm not sure whether I want to relocate to Kintampo or to Navrongo. Maybe you can help me decide. But I told him yesterday when I went to see the exhibition that, well, I don't know what all of this means for someone like me who doesn't get malaria. And I've given myself up for Wagbeb and Noguchi and all allied institutions for research. So we see what's happening. We suspect it has something to do with my genes, but we need research to be definitive about it. I'm sure that there are some of us in this audience who thought that we wouldn't survive an hour plus of a scientific class. Yet it's been enjoyable. I've learned more about genomics, pathogens, cytokines, and so on. I've learned that I don't have to pamper pathogens. We should just ignore them and we'll be just fine. The other lesson that I learned was that preparedness is important. WACBEB and the other institutions here at UG, Noguchi Memorial Institute for Medical Research were able to do what they did during the height of the COVID period because they had the resources. What they needed to do was the resources were meant for something else, but what they needed to do in the heat of the moment was to redirect those resources. If we didn't have the resources in the first place, we couldn't have provided that level of support that we provided for the country at that time. So again, we make the case that we do need more resources and we can do even better. The other lesson is that we need to continue to build capacity, and it has to be done here in Africa for Africans. We've seen the retention rates of the PhDs produced at WACBEB. When we do train Africans here for Africa, we have a high retention rate. WACBEP has shown the way. We have homegrown and globally competitive Africans who can hold their chest anywhere in the world and do quality research. Last Monday, I was on a radio station in Monrovia. I was talking about UG, and they were asking about scholarship. I was able to say that here at UG, we offer scholarships thanks to institutions like WACBEP, WACI, WACMEG, and so on. So it doesn't matter where you are in Africa, like he said. You just apply, go through a competitive process, and you can come on board. Now, I learned some lessons about the man himself. Professor Awandare has incredible talent, but he's shown that we can't make it with talent alone. You need to combine it with restlessness, non-conformity, and be passionate. You don't say stop till you get to your destination. No wonder the mantra at WACBEP is no excuse, just get it done. Prof has shown us that when you suffer disappointment, you don't give up. You keep going. He's shown incredible resilience. Yes, he couldn't get into medical school, but now he has achieved so much as a malaria cum-COVID professor. He's demonstrated that collaboration and cooperation can achieve a lot. He's built an incredible team, provided support for young people, so that now I can send him off to a number of meetings, yet the scientific work at WACBEP will go on. He talks African, not Ghanaian, providing opportunity for the whole continent. That's how big his vision is. I knew some of these about him, but what I didn't know was that he created businessmen as well. Congratulations, Prof. You've done amazingly well. My only disappointment, though, was your attempts to discount the divine intervention when you are planning to start a church. I don't think he will be a successful pastor. Don't join his church. Truly, the man from Kandiga, born in Bolgatanga, schooled in Navrongo, Accra, and Pittsburgh, can be described as a giant of an African scientist. Professor Gordon Akanzuweni Awandare, well done. Keep going. You have done excellently so far, yet there is more to be done. Until there's a critical mass of African scientists in Africa with adequate funding, producing vaccines which are both available and accessible and affordable, you cannot stop. Thank you for showing the way. Thank you for giving hope for African scientists. We're truly proud of you, and all that we would say is that keep going. Thank you to you, our amazing audience. It's been a long evening, but you've stayed with us. You make me feel like doing another inaugural lecture. Thank you all. When you hear our call again for another lecture, please join us. Come and see what we do here at UG. come and see what we are made up of. Thank you all, and may God bless you.
Thank you, and God bless you as well, Madam Vice Chancellor and Chair. We thank you so much for the succinct summary of the lecture. If you didn't get anything at all from the lecture, VC has given you summaries to take away. Thank you very much. I would like to add my voice to the Vice Chancellors to thank all of you who joined us for this lecture. Those who joined us online, and I'm happy to say we had Professor Lydia Aziato, Vice Chancellor of the University of Health and Allied Sciences, together with other dignitaries and invited guests joining us online. All of you who could make it physically, we cherish you all. We thank you so much for joining us. As the Vice Chancellor mentioned, we will be very grateful if you could honor our invitation to our subsequent lectures. On this note, I would like to announce our next inaugural lecture, which will be delivered by Professor Justice Novinho of the School of Public Health, College of Health Sciences, on 27 July 2023, here in this hall. Prof. Novinho will be speaking to the topic, the pursuit of health amidst scarcity, economics, and the romance in between. And we invite you all to be part of this lecture. I believe you are not going to miss. Remember, we've started a congregation, so we need you all here for this lecture on 27th July 2023. I'm also happy to inform you that we're still celebrating our 75th anniversary. And so we have programs on our 75th anniversary. Please watch out for our publicity and join us for all our 75th anniversary programs. We also have our 75th anniversary logo beautifully displayed there. We invite you all to take pictures and share on your social media platform. And remember to use hashtag UG is75 when you are sharing. Thank you very much. For our order of refreshments, we will have our senior members and guests on the north wing of the Great Hall, which is to my left, outside, the wing there. That's where we are going to have our senior members and guests for refreshment. And then we will host our staff and students at the AA Kwapon Quadrangle, which is the forecourt of the Great Hall. Before we recess, we have our Chancellor here. And so, after the university anthem, I will invite the platform party to join our Chancellor and our former Vice Chancellors who are in front for group photographs before we proceed with the recession. On this note, distinguished ladies and gentlemen, please let's rise for the university anthem.
Is
the Vice Chancellor and all officials on the days to join the Chancellor and our former Vice Chancellors and the dignitaries on the front row. The photographers will conduct us to take a group photograph down. Hello. Let's rise as the platform party recesses.
Good evening, ladies and gentlemen. You are listening to Ɔdadeɛ Radio via the Ɔdadeɛ Radio app and on Zeno Radio app. You can follow us on Facebook, Instagram, and Twitter at Ɔdadeɛ Radio. You've been listening to Ɔdadeɛ Radio, and here at the Great Hall of the University of Ghana, the Inaugural lecture Professor Gordon Awandare, a proud Ɔdadeɛ of the 1991 year group, on the topic how our immune system acquires tolerance to malaria and helped us survive the COVID-19 pandemic. I have a lot of interesting people lined up to listen to us.
Hello.
And so just stay tuned and enjoy.
Hello, hello. All right, so ladies and gentlemen, hello.
Yeah. So you go see this air. So this is office is this. Or in life. As you like, you need the like what is yes.
I want my cable for my TV.
Your cable for TV.
The power cable, yeah.
Let me go out the TV.
You own? No, I don't know that. Where the power cable?
Emuna.
Bien pour toi, tu as beaucoup de
Videos. More top in now. Channel me video. One day, we are most stressed. I don't know. I don't know this time. We don't know. Good evening, ladies and gentlemen. You are listening to Ɔdadeɛ Radio via the Zeno Radio app or the Ɔdadeɛ Radio us via Facebook and on Instagram and on Twitter at Ɔdadeɛ Radio. I have here with me a student from Senior High School, and I want to ask a few questions about what she learned from the lecture today. Hello, Basma.
Yes, Basma Mohammed.
How are you doing?
I'm fine.
All right. So I want you to tell me a little bit of what you heard from the lecture tonight. Okay.
So the lecture today taught me that our immune system gets used to malaria in a way, and it has in a way also helped us in COVID-19, in the fight against COVID-19, and it has also broadened the knowledge of the students on biology, and has shown us that there's a broader world of biology that we can also be part of.
Are you a biology student?
Yes.
Okay, so I can see you're very happy talking about biology and stuff. Yes. So like, has it influenced your decision? I mean, the course you're going to make in the university?
Okay, it has not really. It has taught me to do more research, but it hasn't influenced the course I'm willing to pursue in university.
Okay. So I'm super grateful for your time, and I hope are you intending on coming to the University of Ghana?
Yes.
Okay, then I hope under the influence of Professor Gordon Awandare, you'd impact so many lives, because he went to Presec, and then Presec and then Preset are like sister schools,
yes.
So you are in a good place, and then I wish you all the best in your endeavors.
Okay, thank you.
You're welcome.
Thank you.
All right, so thank you so much. You just listened to a student of Pacesetter Senior High School, and so I have more people I would be talking to later, and so I'm just going to fish a little out, and then we are going to be with them very shortly. Thank you so much. You are still listening to Ɔdadeɛ Radio. Don't go anywhere. I'll be back. Thank you.